My name is Dr. Alanna Rebelo. Palmiet, or Prionium serratum, is a wetland plant. Plants typically grow to about 2 meters tall, and palmiet once filled the many rivers and their associated wetlands throughout the Western and Eastern Capes. Interestingly, palmiet is fire adapted and stimulated by fire. What is quite special about palmiet is its propensity to form dense stands, which seem to be groups of plants, but which are often clonal systems. This means that naturally, palmiet plants tended to form these large wetlands covering entire valley bottoms, especially in open valleys where fire would have swept right across the riparian zone, which would have precluded riparian forest species. It's in the way that palmiet is able to change its environment that is important for humans and can deliver very important ecosystem services to society. As palmiet grows and colonizes valley bottoms, the system starts to trap sediments and organic material in these dense systems. And unchanneled valley bottom palmiet wetlands are actually able to maintain quite a high water level, such that not all of this organic material breaks down. In other words, some of it is trapped underwater all year round. And what this means is that decomposition cannot take place because there's no oxygen, and this form results in the formation of peat. It takes thousands of years for peat to form. It is this peat which really delivers important ecosystem services to society. Some of the benefits have been shown to be that these wetlands are able to actually reduce the force of floods in high energy catchments by dissipating or spreading out the flood waters. Another benefit of palmiet wetlands is that they behave a bit like a pure carbon filter. They are very good at cleaning water, taking up nutrients and trapping sediments, and removing toxicants. Also, palmiet wetlands help to combat global warming. This is because these wetlands are able to sequester or trap carbon. Palmiet wetlands are also important for biodiversity maintenance. There's many endemic plants that rely on these ecosystems as well as fauna. And lastly, palmiet wetlands are also a part of our cultural heritage. South African palmiet wetlands are in decline. Palmiet wetlands have also become increasingly fragmented. The major driver of this degradation is agriculture and gully erosion triggered by land use change. Associated with this agricultural impact, our research has shown that water quality is close to pristine in healthy wetlands. There are a couple of myths about palmiet, and one question is, does palmiet clog up the river? Many landowners are deeply concerned that palmiet blocks the river, and therefore have removed palmiet by bulldozing the river or the wetland to create an open channel. And this is a huge issue because it's due to the ability of palmiet to slow the movement of water in the landscape that it provides so many services to society. So when palmiet is bulldozed and a channel forms, several things can happen. Firstly, you could get erosion of the soils and the bedrock beneath the wetland exposed. We see this in the Berg and Breede rivers where the river channel has been incised and a donga formed. And this means that an abiotic or unliving threshold has been breached, making it very hard to restore the river. Erosion also reduces the agricultural potential of the adjacent land by lowering the local water table. Number two, the water quickly flushes through the system in the channel, and therefore water is not able to be cleaned by the palmiet wetland as it passes through. The water is not slowed down, and so sediments do not settle out, and nutrients and toxicants are not removed from the water column. And thirdly, flood risk increases because the water is not dissipated or spread across the wetland system, but rather flushed out through the channel at high speeds. Now, probably part of the reason for landowners feeling that palmiet clogs or blocks the river is that we often have rather European mindsets about what rivers should look like. An open channel with freely flowing water. However, in many cases in South Africa, this is just not the case, and it's perfectly healthy to have an unchanneled valley bottom wetland where you don't actually see the river. Another part of the reason is that we've encroached too close to the river systems with our development and our agriculture. Another misconception is the one that palmiet is a water guzzler. Open water evaporation can be higher than evaporation through plants and in palmiet systems. Palmiet, and this is the important part, it uses far less water than invasive alien trees in these same areas.
Collecting palmiet seeds has got various challenges. So again, it's the biomimicry way that gives us a lot of clues on how to collect the seeds and also when to sow the seeds. So I'll just quickly run you through the process. So the flowering time is normally from October to early November, and then the seed starts ripening up around about November time, but it all depends on the season. The seed heads are formed on long stalks, and they're distributed. When the southeaster blows, they are rattled out. They've got small capsules that burst open within the seed head. When the seeds are ready to collect, you need to be quick and get them. If you are late, you can be up to a week late and then you can hardly get any seeds. So your timing needs to be very specific. Collecting palmit seed is difficult. Getting into the plants to the seed is climbing over a bit of a jungle gym. Palmit is structured a bit similar to a tree, but you can actually just see the branches. So you have to climb over the branches to try to get to the actual seed heads, and that's quite challenging in its own. Once the palmit seed heads have been collected, we dry them out and then we put them through a chipper. Once the chipping process is completed, we put them through a sieve. We sieve them, and that separates all the useful and unuseful material. From there on, we go into the sowing process. The next phase is to germinate the seeds. It's very important to germinate fresh seeds. So as soon as you've sieved your seeds and separated all the stuff that you wanted, you can sow the seeds. The soil mixture we use is what we try to mimic nature again. So it's generally a low pH and a peat sandy mixture. That seems to have been giving us the best results. And you sow the seeds just on top, just as you would do in nature. And then you keep it moist. It's very important to keep it moist. As soon as the humidity drops, you will lose the plants very quick. Growing palmit from cuttings is definitely an option. One will carefully have to evaluate your site to see if the palmit population that is existing is strong enough to handle it. So as you would take quite a lot of material to do the cuttings. The cuttings can be done from September to November so that the plants have enough time to root before the winter. Otherwise the floods will come and they'll just wash them all away. If the plants are done from December to January, you also have a higher chance of losing them through humidity dropping, and then just the cuttings don't survive. Staff takes about 30 to 50 plants per day per person, versus seedlings which are normally about 1,000 plants per person per day planted. So if you compare those two, you can see there's a big difference. So it depends on your objective. Palmit cuttings take about a year to flower and to produce seeds. Seedlings are slow, and they have to outcompete invasive aquatic weeds. So in nature, palmit seeds germinate in very specific environments. If you think of palmit seeds being distributed downstream from wherever it came and on the site, it will germinate on areas that are generally out of the flood reaches of the main energy of the flood. So that will be on the inside corners of the flood. So that's where we're going to try to focus our palmit planting so that they can survive. To some extent you want to have the palmit on the outside corners to reduce the impact of the water flow, to reduce the energy, but the palmit plant won't survive there. So why do we plant the palmit plants? From Alanna's talk we've already heard that palmit slows the energy and allows the positive natural deposition to happen, and that's what we want to encourage. And the Berg River, it's become very, very hard to do. The water is released from the Berg River dam. That makes the summer low flow water fluctuate, and planting palmit then it becomes incredibly difficult. Tools to use for planting palmit: we've got a soil auger that we drill holes in if it's sandy soil. Then the palmit cuttings can be stuffed into the hole. It's really important so that the main crown of the palmit is facing downstream. So if we do get some sporadic floods in summer, it won't necessarily wash all of them away. There's a couple of places not to plant palmit, and one needs to be aware of them as you want to start planting. If there's any bridges, be careful of not planting palmit dense in front of the bridge. That could potentially have an effect on the flow. Secondary channels should be observed, and planting in front of secondary channels should be avoided as far as possible. If there's islands forming inside a channelized system, that should potentially be avoided as well. For channelized systems are man-made, and if you plant palmit in there, it might cause erosion. Palmit is one of the most important plants we've got on the river system. Certainly not the only plant. So palmit is part of a bigger system, but palmit should definitely be highly valued for ecosystem services. The process of degradation of palmit is actually quite a simple process. You can hire a yellow big machine and you can just destroy the palmit. But getting them back in and getting the system back functioning is hard work, and it should be avoided as far as possible.